Well, hello and welcome to this brief tutorial on osmogenics, or the science of power generation through osmosis. We are generating power today for tomorrow in a truly green and in an effective manner. What we'll do, we'll talk about the basic principles very, very briefly, one slide, and then we'll go on to the practical applications of such a osmogenics system. Right, moving on. In the left-hand side of this page, we have a jar of water, blue water filled with red bits. Initially, the red bits are in the top left-hand corner of the jar of water, but they won't stay that way for very long. Eventually, they will diffuse and the molecules will be distributed evenly throughout the volume. Now, if we go to the top right-hand corner, we can see a container with fresh water in, separated by a semi-permeable membrane from the right-hand side of salty water. And the fresh water seems to be going through the semi-permeable membrane to try and dilute the salty water. Now, how is this occurring? Well, if you go to the bottom right-hand corner, we can see once again a stylized container with the blue dots representing the water molecules and the red dots representing the table salt. I was going to say molecules, but they're not molecules. It's an ionic liquid, and therefore they are ions. And I know ions are small, very small, tiny, so they should be able to go through that semi-permeable membrane, but they can't. Why? Because the theory is that they are ions and they attract elements, or not elements, the certain molecules, water molecules are attractive, and they attract rather like the paparazzi around a celebrity. They cluster. Their effective radius is therefore bigger than the ion itself because they're attracted. The water molecules around them are attracted to it, and they stick. And so the red dot cannot go through this semi-permeable membrane from right to left. But the more plentiful water molecules on the left-hand side can easily transport themselves from the left-hand side to the right-hand side. Now, there is water molecules on the right-hand side as well, and these do in fact find their way through diffusion again from the right-hand side to the left. But because there are so few of them, relatively speaking, compared to the left, the majority of water flow, the flux, goes from left to right. Now, this net flow of water from left to right increases the volume on the right-hand side of the jar, and this can, in effect, is the osmotic pressure. Now, this osmotic pressure can be huge, 100, 150, 200 psi. It really is huge, and this is where we can start to try and harvest that pressure for power generation. What systems do we need to harvest that pressure? Well, we need a little jar, a tube, a container with the osmotic membrane in. And we feed the water into that osmotic tube, and then we feed strong saline solution around it. What happens? The water then diffuses, or through osmosis, into the strong salty solution, trying to dilute it, and this gives us high pressured brine on the output. Now, how do we harvest this? Well, quite straightforward, really. We put a valve on there, so we fill it up with salty water, then we close the valve so no pressure can go back up into the strong saline solution feed source, and then we have a pressure gauge where the high pressure brine then drives a turbine. The idea is using a Pelton turbine because they're very efficient, amazingly so, 90% or more, and that drives some form of generator. We need a little bit more than that to make a practical system. For example, we need some automatic non-return valves in the strong saline solution there. We could do with a valve to regulate the flow of this pressure feeding the turbine, and we need an evaporation tray to catch the brine. The sun will then evaporate the water eventually if it's big enough, and then we can just feed that salty water, much stronger salty water, back into the strong saline solution feed and start the whole process again. So this is really a very efficient, green, and continuous form of power. This is continually producing power whilst there's this a potential gradient between pure and salty water. Right, to make it a little bit practical, we put in a bladder, a pressure bladder vessel, so the high pressure brine then pressurizes this air, so we try and level these peaks of these of this water coming into the brine, and then we can control more finely the turbine, making sure it's operating at its optimum speed and flow. Now, this is just a one-cylinder engine. It can be equated to a one-cylinder engine, and we need more than one cylinder. How do we do that? Well, we add more pipes, more valves, more controls, more monitoring, and we then add a completely new pipe on this end. So we just add more of these osmotic membranes and these power pipes. Now, this is the full system that we envisage. We have a strong saline solution, basic filter, electrically operated relay, spring return, non-return valve into this osmotic membrane. Now, at the moment, we're using reverse osmosis mechanisms, which is not particularly brilliant because we find we have to clean and reverse charge this membrane on a regular basis, but it doesn't really matter because we're going to have more than just one pipe. We can have a dozen, 2, 3, 4, 10. It doesn't really matter how many we have. 2, 3 dozen, 10? Never mind. And so we keep the idea, we keep the pressure on this bladder high so that we can release it into the turbine and continually generate power. This is the process, the charging process, set the valves, etc. But it's not bothering to talk about that at the moment. But the idea is that we keep many cylinders firing, and we keep a continual strong flow of saline solution and rainwater coming in to keep this power going. Right, we don't need all of this though for the first system. This is all we need. Take all the star things out, we don't need any of that. So the basic system will be this. And that's what we're generating now. We have made some. It does seem to work, although we haven't got the Pelton turbine mechanism sorted out because the flow is not high enough. So we definitely need more organ pipes to keep the flow increased. But there's no limit really on the number of pipes we can use, and a little computer could manage all this quite easily, monitoring and controlling the firing of these osmotic systems. That gives us the basic outline of the Osmogenics, the science of power generation through osmosis. It is a truly green system, and I believe it is engineering power today for tomorrow. And if you want more information on how to make one practically, well, help yourself. And thanks very much for watching. All the best. Cheers then. Bye-bye.